All right, so we're going to continue on here with these things called keyword arguments. So we've been talking about these arguments, and thus far, the arguments are what we would call position dependent. Okay, position dependent means the arguments passed in are position dependent on the parameter variables. Okay, so for instance, when I call add 3 with this value 2, 2 will go into A and 4 will go into B. Same thing here is the value of A, which is 5, 5 will go into A, and the value of B, which is 6, will go into B. So this will be 5 and 6. In this instance, it's going to go 2 into A, negative 9 into B. Okay, so it's very, very, very order specific, okay? There are ways, though, to make it not position dependent. And the ways that we make it position dependent is by using things called keyword arguments, which is an argument that specifies which parameter the value should be passed to. Okay, so the way that we sort of use that is this general format here, which is function name. Then you give the parameter, and then you assign it a value. You assign it a value of some sort. So I could say length is 5 or whatever, okay, which means essentially no matter how I call that function, that will have a default value to it. So oftentimes we use these keyword arguments as sort of a way to create default values and a way to create maybe missing arguments should a missing argument occur. Now, you can mix positional arguments and keyword arguments together, but the positional arguments have to come first, okay? So that's essentially how those arguments are going to work. So coming over here, if I wanted to do a positional argument, I could actually say here length equals 7, right? So I have this function call that I could actually just set it up and make it to what it is. Now I can actually run that, and it just has the same thing. But what's cool is now I actually can reference that length if I would like to. Okay, so now I have actually referenced that link, and I actually can print that out. And actually, let's make that something that we can recognize, 700. All right, so now when I run it, I can actually print that 700 every time I call add 3. But what's neat is I'm calling this with only 2 values, right? Well, let's say randomly I want to go ahead and call with some other value. Okay, so now I have 2 and then I have 3. You'll notice that when I get to this point, we're going to see an 80 printed out. Okay, there's my 80 right there. Okay, so it's one of those situations where you may have a optional value that needs to get passed into a function. Well, you can actually use these keyword arguments to sort of set that up. So sometimes it may be that you're going to have, say, a name. And you could just sort of set that to empty if you need to. And it may go in, it may not. Okay, so I may send in Adam here, or I may not. If I do, then I actually have a value. If I don't, then I don't have a value. Okay, so that's what a keyword argument is. Now remember, positional arguments must come first. Positional arguments come first, and then keyword arguments come second. And then the order of the keyword arguments is completely irrelevant because I'm specifying exactly what that's supposed to be going to. Okay? All right, so that's your keyword argument. So moving forward, we have global variables and global constants. Now, I've obviously mentioned a little bit about global variables thus far. Essentially, global variables are created by the assignment statement written outside of all the functions. And I believe we still have those written here. So I have length, height, and width. These are available as global variables. Essentially, main can save into width and read from width. Add 2 can save into width and read from width. Add 3 can save into width and read from width, right? And they all 3 can simultaneously do that. And if we have a highly parallelized function with some sort of a multiprocessor functionality, it could actually be trying to write at the same time, and it can cause some significant errors. So again, they can be accessed by any statement of the program file. It's really difficult to track sort of what they're doing. And sometimes you can redeclare them within your function, but it's not absolutely required. You can get away without actually doing the global variable name. Now here's the main issue with these global variables and global constants is, and actually not necessarily global constants, but global variables. Global variables are an issue in that they make debugging really, really difficult because you don't know exactly where that variable is changing or where the error is occurring, because many, many, many locations in the code are referencing that same variable, and who knows when it's getting changed, who knows how it's getting changed, and who knows from where it is being changed. And again, functions that use those global variables are usually dependent on those variables, right? So if something makes a mess of that variable, then that function is going to fail. And at the same time, it makes the function itself less modular, right? It says it here, makes the function hard to transfer to another program, because then you have to transfer out that variable as well. So it's always better to avoid a global variable as much as possible. And again, they can make it really, really difficult to understand. So these global constants, sort of like a named constant, it's a global constant which is available to everything, but it never changes, right? So it's a global name that references a value that cannot be changed. And this is a lot better. They may warn you away from this, but this is really, really great to avoid magic numbers. I mean, if you have some sort of a program that references these sort of global constant values, say it's a physics program and you're actually using like 9.98 or like G or some sort of a value that doesn't change, you can actually put that as a global constant because it's never going to change and everything can just use it where they need to. But it's really nice because since it's not changing, you're not really worried about that thing getting mixed up. So I would highly suggest you use global constants. I would highly suggest and actually request that you avoid global variables. So again, a global variable is this, and a global constant is going to be more like this. Just call it global var for now. Okay, so that's a global var. That's going to be a global, or sorry, not global var, a global constant. Okay, so that one's not changeable. Those ones are changeable. This is fine because you're never writing to it. These ones aren't that great. Okay, so everything capitalized is a constant. So again, avoid the global variables, but you can go ahead and use global constants if you need to. All right, so we've talked a little bit about functions that have values coming into them. So we have, say, A and B. We have some numbers, maybe a name, maybe some keyword arguments. So we have a lot of stuff coming into this function. We have a lot of processing happening. Maybe we're summing things up. Maybe we're making areas. Maybe we're finding an average. And then at this point, we're not really returning anything back. We're just sort of printing something out. But there are times when it's really important, like, say, creating a mean function, right? So I'm going to send in something and I'm going to calculate the mean and then I'm going to return that average out, okay? That's really, really useful because I want that average and I may want to do something with that average rather than just print it to the console and leave it alone, okay? So again, that void function is a group of statements that just performs the task and doesn't do anything else. So we have the solution to being able to get a value out by these value returning functions. So again, they're similar to void functions, but they actually return something. They don't just print something out. They actually return a value. So in these value return functions, maybe I'll return the area. Maybe I'll return the user input. Maybe I'll return the mean. Maybe I'll return the median. Maybe I'll return the mode. You know, there are a lot of different things that we can do with these functions. Now, as we've seen already, there are things called standard library functions and standard library functions. So we've seen the standard library functions, print, input, range. Essentially, they are defined by Python when you install them. So I can use print, I can use input, I can use range. I don't need to do anything. I can just go straight into my code, and I can just use print without having any errors or any problems or anything like that. Okay, I can just use print, I can just use input, everything's fine. I don't have to have any special statements. I don't have to do any installation. It just works, which is fantastic. So these functions are called standard library functions. Okay, they're pre-written functions that come with Python, or kind of look at them as a black box. They all work. They're robust. They are highly tested, and they are very, very functional. So again, some of these functions they're basically built into the Python interpreter. So basically, you just call the function and it works. So like print and input. There are other functions that are available to us that have been written and they're robust and they work very, very good, but they're not imported automatically whenever we run that script. And the reason why they do that is because if you import every single available function that you can into every single script you run, it'll get very, very, very slow. You would hit play and it would take 5 minutes to import everything, and then you would finally execute your program. So the standard library functions, those are the ones that are just necessary, that everybody's going to use, that's going to get used often. Those are the ones that are just automatically imported into your script. So again, your int, your float, your input, your print, your range, functions like that you're going to use regularly. But there are some that if you want to use them are available to you, but you must import them. So they are already in the Python directory under packages. They're already there for you. They're already installed, and they're just ready to import. Okay, some of them you may have to install, and we'll cover that. But there are a lot that are just readily available. And what these are, these functions that you may want are stored in things called modules. So these are files that store functions of the standard library, okay? So the standard library itself has the ones that are in the interpreter, but it also has these modules that are available to us that we can import from, okay? So it helps organize library functions, and it's copied to your computer when you actually install Python. So to grab a function out of your actual standard library that's not included in the interpreter, okay, so what I mean by that is not using something like print or input or int or range to use some other function that's available to you, you have to actually reach into the standard library and import that function or that module. Okay, so again, to call a function stored in a module, you need to write an import statement. So import is a key word, import. And I want you to memorize that. Import, 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 import. And anytime we do imports, you can literally, it's legal to put them anywhere in your program. But the Python standard is that you put it at the top of your program. Okay, so I want you to make sure that you put that at the top of your program every single time. And the way that it works is it's import module name. This is the sort of syntax to go ahead and import stuff. And that's sort of a visualization of what that looks like. Okay, so we're going to take a little bit of a side path. It seems like a tangent, but it's not really a tangent because it deals with this import functionality. There are a lot of times in computer science when we want to just be able to generate a random number. Maybe it's a random number of any sort. Maybe it's a random float. Maybe it's a random integer. Maybe it's a random number in a certain range. But it's very, very useful, especially in cybersecurity, cryptography, to be able to generate random numbers. They're very useful in a lot of programming tasks. Well, in the standard library of Python, we actually have a module called random, and that includes some library functions for working with random numbers. And I'm just going to show you how to import random first before talking to you about dot notation. So as we mentioned previously, I don't just have this random module available to me. I have to import that module in. So the syntax for that is import random. Okay, and we can actually see that right here. We're going to import random. Now with dot notation, which I'm going to come back to, then we can access stuff inside of that. So let's go over to PyCharm. And so if we want to do something where we can import a random number, let's just start from scratch. So obviously I'm going to type MA enter. If name equals main, then I'm going to type the main call, okay? And then I'm going to define my main. Oops, you want to define that at the very top. All right, so now I have my main method. I'm going to go ahead and do a pass there just to make it a filler. And then let's go ahead and deal with this import. Okay, so here's how you do it. You do import random. Simple as that. It's a very, very, very easy task. What's interesting is now random is available to me as random, right? So I can reference everything inside of the random module. It's sort of like a folder by using the random keyword. But I can also call that something else, right? Like I can import random as rand. Okay, so now it's imported as this variable named rand. Okay, so if I want to use anything inside of that package, I need to reference the name rand. If I don't do the as, then I can just reference random. So sometimes it's easier to just do R, right? So now I can reference it as R, or I can reference it as RA or RD or whatever you want to call it, right? It just keeps you from having to write out the whole word random whenever you want to use that, okay? So we're going to talk about dot notation on the other side of the little break here. We're about 13 minutes. So go play around with this a little bit. Practice doing your if name equals main, setting up your main, and doing the import random, and then come back on the other side. Let's talk about dot notation and actually generating random numbers.